Okay, problem number 2. Let f prime of x equal this. Okay, notice this is the first derivative. So then it says there are 2 points of inflection on the graph of f. Write down the x-coordinates of these points. So to find points of inflection, we need the second derivative. We already have the first derivative, so all we have to do is take the derivative of the first derivative, and we will get the second derivative. So 3 times negative 24 is negative 72. X squared, 2 times 9 is 18, 18x plus 3. Okay, so now to get the points of inflection, we set that equal to 0. So negative 72x squared plus 18x plus 3 is equal to 0. One thing I noticed is that I could factor out 3. I'm actually going to factor out negative 3. So negative 3 times 24, and then negative 3 times negative 6, and negative 3 times negative 1. And then I'd look to see, can I factor this? So to get a negative 1, I'm going to have a plus 1 and a minus 1. So then I'm looking for 2 numbers that multiply to give me 24, that add to give me 6. So 6 times, let's see, so 1 times 24, that's not going to work. 2 times 12, that's not going to work. 3 times 8, close, but nope. 4 times 6, and then I'm done. Okay, so it can't be factored. It cannot be factored. So how else could we solve this? We could use the quadratic formula, or we could do completing the square. Or if this is on the calculator part of a test, I could use the calculator. So noticing that this is only 3 points, this is 1 point right here, setting it equal to 0 and recognizing I have to solve for x would be the second point, and the third point would be actually finding the x-coordinates. So I could use the quadratic formula, or I could just use my graphing calculator. So if I do the quadratic formula, I could do it with the original equation, or I could do it with just this part right here. If I do it with the original, x equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. I could do that and simplify that, or I could put the second derivative into my calculator. I could put in negative 72x squared plus 18x plus 3, graph that, and I'm looking for the x-intercepts because I want to know when does it equal 0. So I am going to do second calculate. I want my zeros, those are my x-intercepts. Left bound, I don't even know where my cursor is. Where's my cursor? There it is. Oops. Okay, left bound. Right, ooh. I think I should probably zoom in. Hold on, let's zoom in. Let's get closer to these, I can't see it. So I'm moving my cursor, I'm zooming in close to the x-intercepts. There we go. All right, so second calculate zeros. And left bound, where am I? There I am. Why is this jumping so much? Enter, right bound, enter, and guess. So it gives me negative 0.114. So x equals negative 0.114. That's 3 significant figures. And then the other one, so I want the left bound. Where is it? There it is. And the right bound, enter. And I get 0.364. 0.364. So there are the x-coordinates of the points of inflection. And that's all it asks for, just the x-coordinates. I do not need to plug them back in. Well, I don't even have the original equation, so I couldn't plug those back into the original equation to find the y values. All right, so let g of x equal this. Okay, so g of x is equal to the second derivative of f, 72x squared plus 18x plus 3. And it says, explain why the graph of g has no points of inflection. Okay, to get points of inflection, I would need the second derivative. So let's take the first derivative, and I would get negative 144x plus 18. And then take the second derivative, and I get negative 144, and that's it. So to get the points of inflection, I would set the second derivative, negative 144, equal to 0, and solve for x. There is no x, so this explains why there is no points of inflection. I can't solve for x. But what would be a better explanation is to actually graph this and show that y equals negative 144 would be down here, right? Sorry, I should go through there. Negative 144. It's a horizontal line, so therefore there are no x-intercepts. There are no x-intercepts. Okay, because the points of inflection are the x-intercepts of the second derivative. And there are no x-intercepts, so therefore there are no inflection points. Okay, that's it.